In this video, we're going to take another look at database diagrams. I've already opened one for you here, and we're going to look at the customer address, and the address table. I've selected these three tables, and I've changed the table view from column names to standard. And standard is giving me more information than about the attributes of each one of the fields. We're going to start with the customer table, and we're going to be dealing with only the relationships between the customer table, the customer address table, and the address table. We're not going to be dealing with these other relationships that you see coming in from up here. With the customer table, each field that is in the customer table needs to describe the subject of that table. In this case, all the fields describe the customer. There are a couple of exceptions in all of these tables, and that is the globally unique ID and the modified date. And that describes the data more than it describes the subject of the table. And we will not be using these particular fields in our select queries. We won't be joining on them. They are fields that describe when the data was last changed. They give a specific global ID to that row so that it's not confused with any other row. But these are not fields that we are going to use for information, and they're not fields that we're going to join on. The primary key in the customer table is customer ID. Now, how do I know that? If I come over to the customer table and I expand this, I can look at the table and I see that PK is identified as, this is the primary key, and it's pointing to the customer ID. PK, and we also see that the key is gold. Now, that's just a visual symbol, but what we're interested in is that it actually says PK. We can also go in and look at the properties for this particular field. I look at the extended properties and I see that it is the primary key for customer records. In this particular table, there is no foreign key. A foreign key is a primary key from another table. So customer is the primary table. If I want to find the tables that are related to the customer table, I will need to look for tables that include the field customer ID and are using it as a foreign key. And over here in customer address, I see that customer ID is included. It's showing as a primary key, but let's go and look at the attributes. It is a primary key and it's a foreign key. So let's look at the properties on this. It's a primary key and it's a foreign key to customer.customer ID. So it's a foreign key to the customer table, the customer ID field. A primary key by definition is unique. So there can only be one customer number one. A foreign key does not need to contain a unique value. So as we take the primary key from this side and we bring it to the related table, we're creating a one-to-many relationship. The yellow key in the database diagram in SQL Server is showing this is the one side. The sideways 8, which is really the infinity sign, is showing the many side. And if you want to make this work for you, you can bring the key up so it points to the key, and then bring the infinity sign down so it points to the related field. When you hover your mouse pointer over that particular line, it also tells you that there is a foreign key relationship. And when I look at this, I can look at the keys, and it also tells me that I have a foreign key relationship between the customer address and the customer table on the customer ID field. The two fields here together create the primary key in the customer address table. And we can see that by looking at the primary key and seeing that it's composed of customer ID and address ID. Because these two fields are taken together to create a composite primary key, it means that the two values taken together, customer ID and address ID, are always unique. So customer ID 1 can have address ID 1. Customer ID 1 can have address ID 2. Customer ID 1 can have address ID 3. Customer 2 can have address ID 1. Customer 2 can have address ID 2. But as you notice, as we move from one row to the next, we are looking at unique values in that composite key in each row. Now we're going to look at the address table. In the address table, the primary key is address ID. There is no foreign key. And we'll open that up. No foreign keys. Now, what are we looking at here? What this is telling me is that a customer can have many addresses. An address can belong to many customers. Now, how would we do that? If we were working in a flat file, we'd have perhaps customer ID 1 and their name and their address, and customer ID 1 and their name and their second address, and customer ID 1 and their name and their third address. Or we could have a situation where we've created a table where we have customer ID 1, address 1, address 2, address 3. Now, when you remember back to what's going on in your textbook where you're ensuring that your database structure is sound, whenever we have a field that can have multiple values in that particular field, like address could have multiple values in it, we have a table that's not normalized. And so what we do with that is we put the addresses in another table. So I've pulled the addresses out and I'm putting them in the address table. So now I have a table full of customers and I have a table full of addresses. Now I have to be able to match the address with the customer. So if my customer can have many addresses, but the address will belong to one and only one customer, then I would pull my customer ID and I'd put it in my address table so that a customer could have many addresses, but an instance of an address would belong to one and only one customer. If I have a situation where an address can have many customers, but a customer would have one and only one address, then I could bring the address ID over and put it in the customer table. That's not our situation. Our situation is that a customer can have many addresses and an address can belong to many different customers. So what we have to do is we have to create a linking table or an intersection table or a junction table. And when I look at the junction table, how do I know I'm looking at a linking table? A couple of the key concepts to looking at a linking table is that normally, and this is not always true, but often you will see a composite primary key. It will be composed of the primary key from the 2 or 3 related tables. When you get into a situation where you have 4 fields, 3 fields, 4 fields, 5 fields making up a composite primary key, now you get into a situation where you should create an artificial key. And you'll get into that one in your database design class. So in this particular table, customer ID and address ID create a composite primary key. Every field that's in this table, and we're going to eliminate rogueweed, which is the global ID, and modified date, because those really don't count. Every field that's in this table must describe the subject of the table. The subject of the table is the intersection of customer and address. There's only one field that describes the intersection of the customer ID and the address ID, and that's the type of address. Is it a home address, a billing address, a shipping address, a branch address? What is it? And the only way that that address makes sense is when it is matched with the customer and the address, because the address type doesn't describe the address, it doesn't describe the customer, it describes the customer and the address. And so that's a field that belongs in an intersection or a linking table. Now, to help you understand why product is not a linking table, is that product model and product category are not using the product table to create a many-to-many relationship. The product table is not an intersection between product model and product category. Actually, what has happened here is that the product table has been normalized so that the model information is pulled out of the product, so we don't have redundant information, and it's been pulled out and put in its own table. The same with the product category information. It's been pulled out and put in its own table. So now let's take a look at the fields that are in the product table. Does color describe the intersection of that model and that category? Perhaps. But does it describe something better than the intersection of model and category? Yes, it describes the product, because the product model and the product category could have many different colors, unless our particular model is going to specify the color. What about the list price? Now, does that describe the intersection between the model and the category? Again, possibly. But have you gone onto like a site like Amazon, or maybe even to a car dealership, and you've wanted a pair of, let's just say Amazon, and you've gone on to Amazon and you want a pair of black suede boots? Well, the black suede boots, same model, same size, same suede, but black, cost more than the ones that are kind of a powder blue. So the price describes the product, not the intersection of the model and the category. So when we look for a linking table, we look to see what the fields in that particular table describe. Okay, so what we've looked at in this particular video is when you open up a database diagram, what is it that you're looking at? You're looking at the tables and the relationships between those tables, or among those tables. Why is this important? As we move forward in working with SQL, we have to understand how to join tables. This is you're seeing this in your terminology reviews now, because when we get into it in Module 6, you will need to understand that in this class, there may be exceptions, but what we're going to see in this class is it will be joining tables primary key to foreign key. And we'll always be doing that. We will not create a join between modified date and modified date just because they have the same name. They are not the same field. They don't contain the same data. Yes, they contain dates, but the modified date in this particular field describes the date that the data in this table was modified. The modified date in this particular table describes the date that the data in this table was modified. It's not related data, no more than the global unique identifier is related between table to table. You can join any field that has the same data type, but that doesn't mean that you're going to do that. We're going to be joining on primary key to foreign key. That's how we're going to create joins. So it's very important that when you look at the data diagram that you can follow the path through the database. That's why it's so important to understand this. When we get into Module 3 and we start doing cast and convert, it's going to be very important to understand what the data types are. Because if I want to create a concatenation of the customer name, which is the national varchar or varchar varying character, and I want to join that or concatenate it to the integer, I'm going to have to cast the integer as text in order to concatenate it to a text string. So if I know what the data types are, I'm going to cast the integer as an n-bar char and then do my concatenation. So it's very important that we can look at the tables and look at the database diagrams and understand the path through the database and the type of data. Now if you have any questions about what we've talked about here, be sure and post those as responses to this posting in the discussion board.